Well, hello everyone, and welcome back to my shop. All right, welcome. Today we're going to get back on this 75 Corvette, and I'm going to explain a problem I encountered while I was out. I started noticing when I was out cruising this last time I had it out, and go through the steps I took to troubleshoot it to get it repaired. And it all has to do with how did the headlights cause rough idle on this engine? Stay tuned and let's talk about it. All right, I hear you now. The crazy guy said his headlights caused his engine to have a rough idle. Well, no, this isn't clickbait. This is actually factual. Well, to be more specific, the headlight assembly is what caused my rough idle. And before I get into the specifics on it, I'll go over a little bit of a backstory to it and set it up and let you all know how I chose to approach troubleshooting this and how I eventually found it. All right, well, number one, this is a 75 Corvette, and from the 70s, well, the 60s and 70s, auto manufacturers, they really went all in for using vacuum control to do a lot of the mundane tasks that we normally would have to reach up and turn and move levers and so forth. They decided to use vacuum. Well, actually, it's the air pressure, the atmospheric air pressure that rushes to fill a vacuum is what actually does the work. And so I'm going to use the term vacuum as if it is the actual power exerting force, when actually it's the atmospheric air pressure that does the actual work. The vacuum is what causes the air to rush to fill it. It's one of them theorems or whatever, Bertolli maybe, that they proven back in the I think it was in the 1600s, that if you remove atmospheric air from something, that the atmosphere will do everything it can possibly do to fill that void back up. So vacuum is produced in these internal combustion engines via the pistons going up and down. Now, we like to think that the piston is actually sucking the air in. What actually is happening is when the valves close and the piston is at the very top of its stroke, you've got that little area up above, right? And it's got air in it, of course. Now, when that piston goes down and it starts somewhat seals that cylinder, the space is expanding, which causes a vacuum type effect. In other words, the space is expanded and the air pressure within it drops to, I don't know, for this discussion, let's say it drops to 0, which is in effect removing the air pressure. Atmospheric air pressure outside that cylinder is going to want to get in there and fill that space up. That's just the way it works. So what it does is when the intake valve opens and that piston's going down, the air is going to rush through the opening it can to get into that cylinder. And we're talking about a carbureted engine now. We're not talking about fuel injection. So in a carbureted engine, it's going to go through the carburetor, through the venturi to get into that cylinder. Now, due to that, what did I call it? Ventelli? I can't remember the effect, but it's a shape like this, like an hourglass, you know, other shapes that we males kind of like to see. When the air gets to that constricted part, it causes a vacuum. It causes a drastic lowering of the air pressure. Now, fuel in the fuel bowl it utilizes that procedure to actually draw fuel out of the airflow, out of the fuel bowl, and into the airstream to get down into the cylinder. Based on the size of the jets and so forth, determines the amount of fuel. I think he wanted something like 14.7 units of oxygen to 1 unit of gas. I think that's the way you want it, but I could be off a little bit. But anyway, the whole thing is air rushing down to get into that cylinder to fill it. It's going through the carburetor, and it's going through the intake manifold. What the manufacturers have done is they've put taps on the carburetor, and they've also put taps on the intake manifold to where they can tap into that vacuum effect, all right, to utilize the vacuum to power devices, or like I said, to make it to where the air can control or power those devices. All right, so we kind of covered that a little bit. Now, when you this engine's been running pretty good. I started noticing in the last couple red lights I was sitting at that boy, it was starting to really shake a lot. Now, this engine doesn't have a radical cam. So if you've got a properly tuned engine that's not got a radical cam, it should idle fairly smooth. Smooth enough to put a glass of water on it, all right, on top of the air cleaner. Well, this was really, it was vibrating and missing bad. Now, the steps you'll take if you encounter something like this is, first off, you need to know the history of your engine. These plugs have maybe 1,500 miles on them, the plug wires, distributor cap, rotor. I've been doing work inside the distributor. I put lighter springs in it. I know, or I assumed that it was not needing a tune-up because all the tune-up I previously done to it only had about 1,500 miles. Now, what you can do to make sure that miss isn't in your ignition system is get to your distributor cap where I got this chrome cover on, but I would loosen each spark plug that plugs into the distributor cap, okay? But leave it connected, but loosen it to where you can take an insulated pair of pliers. They actually make a special tool for this, but as long as you got something insulated, you can reach down there and remove one plug wire at a time. If the engine starts missing worse, well, you know that cylinder's firing, and that's not your problem. What you're looking for, so you put it back and you go to the next one. What you're looking for to see if any particular cylinder is causing the miss. Now, again, I'm assuming if you do find a miss with a cylinder, then you could either have bad plug wire, bad plug, or you could have some internal problems to the sticking valve, burnt valve. I mean, you go from there. But in this case, I was pretty sure that my problem was not mechanical, was not due to a tune-up, plugs, wires, or the distributor, or any of that, or the timing, because I know that was right. So I jumped to step 2, which is to see if I've got a vacuum leak. All right. The best way to determine if your engine has a vacuum leak. Now I'm talking about a gasoline-powered internal combustion engine with a carburetor. I'm not talking about fuel injection or a diesel, all right? This is carbureted gasoline internal combustion engine, all right? First off, look, make sure your choke's wide open, all right? Now we're dealing with a warmed up engine. You really can't troubleshoot a cold engine unless you're troubleshooting the choke circuit, okay? So, but we're not, the choke's wide open, so we don't have a problem with the choke circuit. So you're sitting there, you're looking at it, idling real rough. You got your air cleaner off. If you have the stock air cleaner on it that has a vacuum line to it, plug that vacuum line, all right? You don't want any vacuum leaks at all. Matter of fact, even before you do this test I'm discussing, visually inspect your carburetor and your manifold. Look and make sure every vacuum port has a line to it or is plugged. If you have an open vacuum port on the intake manifold or the carburetor, it will cause this problem, all right? So you visually inspect it, your choke's wide open, all your vacuum lines are connected. You do this test, take your hand and cup it over the primary intake, all right? The primary venturis or barrels of your carburetor, be it a 1 barrel, 2 barrel, 4 barrel. Normally with a 4 barrel, the idle and very low speed operation is only utilizing the primary 2 venturis or barrels, okay? The secondaries only come into play when you open it up. You're wide open. That's when you need that additional fuel for the power. So cup over the primary side, all right? And try to cup it as tight as you can. Now what you're looking for, if that engine starts to bog down, then you probably do not have a vacuum leak. If you cover it over and cover it over good and the idle starts to smooth out or increases, odds are you got a vacuum leak. So then that pretty much takes care of the tune up and the mechanical part. You're looking at troubleshooting your vacuum. All right, so I did this test. I did not do I didn't do the tune-up part. I went directly to the vacuum because, like I said, it's only been 1,500 miles since I've done the tune-up on this. And sure enough, I cupped it. My idle started smoothing out, and I said, I've got a vacuum leak. All right, now that I know I've got a vacuum leak, the process of elimination is now to find where it's coming from. First things I would do, and this is what I did, I ensure that the bolts that bolt the carburetor down are tight. Then I make sure that the bolts that do the intake manifold are tight. Takes, a couple minutes, and you may even find that that's the problem. I have actually had a loose carburetor cause a problem similar to this. So you make sure that's all good. Now, like I said, in the 60s and the 70s, the manufacturers really started utilizing vacuum to do a lot of work. So you're going to notice a lot of taps, all right? Some of them will have to do with your smog controls. This particular engine, all the smog controls have been eliminated, and those vacuum sources that comes off the manifold and the carburetor have been plugged. So to make sure that the plugs aren't the problem while it's idling, remove a plug. The idle kind of starts, if it changes the idle in any way, up or down, you can pretty much say, yep, that plug is plugging that vacuum port, so we're good to go. All right, with the 75 Vet, Chevrolet, they really went nuts with the vacuum. They utilize vacuum. First off, you got vacuum going to the headlight assembly. You got vacuum going to the heat HVAC assembly. You got vacuum going to the power brake booster. You got vacuum going to the PCV valve. You got vacuum going to the automatic transmission, the modulator valve. And you got vacuum going to the charcoal canister for purging the fuel vent that vents out when the engine shut down. So you got all these vacuum sources. The best thing that I would recommend to do is to pick the easiest to get to first. And while the engine is running, unplug it from the source, either be it the manifold or the carburetor, and just plug the source with your finger. Not the line going to the device, but you want to plug the source, be it the manifold or the carburetor. I started at the easiest. I did the vacuum advance on my distributor. That wasn't it. PCV. That wasn't it. Modulator valve right here. Wasn't it. And then I've got this other line comes off. It goes through a filter, and it goes through a check valve. Then it goes to my headlight assembly, and it also branches off to get to my HVAC. I decided I was going to check on that. And I'm going to bring you over here and kind of show you where I did that troubleshooting. All right, here's the tab on the intake manifold. This top one here goes to the modulator valve. That bottom one circles around and comes out right here. That is a filter. That is a filter that is on the vacuum line to keep any garbage to be sucked into the carburetor. All right. This is then a check valve, and the thick line goes up front to the headlight assembly. This small line here that's on that check valve, it's teed right here. Sometimes the T will be in different places, but mine's teed there, and one goes into the headlight switch and the other goes to the HVAC. Now, like I said, a 75 Corvette utilizes a lot of vacuum to do its work. Like here's your PCV, here's some plug vacuum ports that went to like the EGR valve and some other smog related stuff. That's all been disconnected and removed. What the Vette does is it uses vacuum to override spring tension in the headlight assembly to pop them up when you turn the lights on, and then to also override that same spring tension to drop them when you turn the lights off. So you actually have a vacuum switch that is part of the headlight switch. Not only does the headlight switch turn the electric on, but it also has a separate on and off switch for the vacuum. Okay. Now remember, I said vacuum is the lack of air. It's not really the power. The power comes from the air rushing to fill the vacuum. But for this practical purposes here, where I'm just utilizing vacuum as if it's the power. Okay. There's also a switch underneath the dash that you can pull down. What that does is when you shut the engine off, eventually those if you leave the headlights up, they will eventually close. All right. The spring tension will override once the air pressure dies out, and once the vacuum leaks out and the air rushes in, it's going to close. So you can pull this switch down and it'll turn off the vacuum going to the circuit and allowing it to bleed down, and it'll keep the headlights popped out so you can service them. All right. So anyway, in my troubleshooting, I unplugged the check valve right here, put my thumb over it and covered it, and lo and behold, my entire engine smoothed out and gained maybe close to 100 RPM. Well, not really. It just smoothed out. Let's say 50 RPM or so, but it smoothed out. And that told me, okay, that's my problem, is this check valve. So one at a time, I pulled the little one off, no change. Pulled the big one off, plugged the valve, and it cleared it. This big line coming off that valve goes all the way up front here, and you can't see it. I might get a light down there, and it goes to a vacuum reservoir. All right, and I'll see if I can get a shot of that. All right, now I'm trying to light it up here, but this is the front and the nose section right here. It's actually part of the frame. It's welded. It's like a cylinder that's welded between the frame rails. That is the OEM Corvette vacuum storage tank, if you will. You know, air is evacuated from that tank and everything connected to it, and its primary purpose is to build up a large volume of vacuum or lack of air. So there would be a large amount of air that would rush in to fill it, and you can utilize that to provide the power to do your vacuum actuated devices. That's kind of a long way of saying just provides a big storage unit for vacuum, okay? or the lack of air. But anyway, that has been, I troubleshot that, and a previous owner had determined that leaked. And there is an aftermarket storage tank that's been put in down there. I don't know if you can see it or not. It's down there in the nose. Maybe I'll come down from the top. But that is not the problem. The storage tank isn't. So you've got the storage tank as vacuum in and vacuum out, okay? Or air pressure in, air pressure out. So you test the output of that tank where it goes to the next devices in the line to see if the tank's leaking. The tank was not leaking, and the next devices that the vacuum goes to, or the lack of air, is called the vacuum relays, and I'm going to show you. All right, here's a vacuum relay, one of the originals. All right, you notice there's a vacuum can here, and there is 3 ports right here, all right? Vacuum is applied to this can to drop the, I think it is to drop the headlights when you turn it off. I may have it backwards, but in one operation, there's no vacuum applied to it via the, no, I have to research that. Here I am giving a little lesson on it, and I can't tell you, but vacuum is applied when in one state, in other words, when the headlights are raised, and it's removed when they're dropped, or it's vice versa. The main thing to know is to test this, you should put vacuum on it. You will see a little rod right here move up and down, okay, based on the amount of vacuum, and it should hold vacuum. This did, as well as the other, okay? These are the 2 OEMs, all right? So it wasn't in the control. In one position, when vacuum is applied out of that can, it comes to this center lug, okay, this center port. I believe in the down position, vacuum goes through the center port and out the bottom, and then it goes to the one side of the actuators. Now, to carry on with that, this is the actuator. You got vacuum on one side and one vacuum on the other, and a big diaphragm, okay? So in the, let's say in the off position, vacuum comes in the center port, out the bottom port. Now, if you need a mighty vac. If you're going to work on any of these vacuum systems, you really need something that can generate a vacuum, okay? So, or remove air. And mighty vacs are a really handy tool. So if you place vacuum on this center port and you cover the bottom port, it should build up vacuum in inches, and it should hold it steady until you remove your thumb. Now, if you actuate this, it should also do the same here. Now, again, I may have it backwards as far as the way the actuating part of the relay works, but the whole basis is no matter what position, the switch is, the vacuum switch is in this relay. Vacuum all goes in here. It should come out here in one position and not leak, and in the other position it should come out there and not leak. All right? In my case, one of these leaked.
in both positions. It didn't, the actuator part of the relay worked good, but the switched part didn't. All right, it definitely leaked. So what that means is the vacuum coming from the intake manifold to the reservoir and then being introduced to this, or it could have been this one. I've mixed them up now. I didn't label them. One of them was good, one was bad. But vacuum is then introduced to the center lug, goes out the bottom with the lights off, and then goes to the actuator, and it should be airtight. In other words, that vacuum, there should be no air getting into that vacuum circuit, and you shouldn't have any vacuum leaks. My case was I had a leak. Remember at the beginning of this I said that my headlights were causing the problem? Well, that's how my headlight assembly technically was causing the problem because of the leak in one of these relays. All right? So, those relays, they reside, I'll get you down here and see. I think you can see there they are right there. All right, let me get my lights swung around here. Okay, and you can see them. So they're kind of a pain to get to and kind of not. And here is your actuator right there. Remember now, you got vacuum on one side and vacuum on the other, and depending upon the relay, which applies vacuum, it either pops the headlights up or it pops them down, okay? And in my case, I had a vacuum leak while the engine was idling with the headlights off and also with the headlights on. The headlights, I should have jumped straight to them because they actuated very, very strangely and intermittently. Sometimes the right side would pop up first and then the left, or vice versa. They never came up simultaneously and they never dropped simultaneously, and sometimes they wouldn't even come up. They would both come up partially and I'd have to help them back up. That's when I was troubleshooting. So anyway, and while I was doing it, troubleshooting, I was glad to know that when I plugged this side here that my HVAC was not having a vacuum leak. And that's a whole nother circuitry that we can talk about. But in this case, we're just talking about the vacuum circuitry going to the headlight assembly, and that's what caused my intermittent problem. All right. I guess proof is in the pudding. We're going to put this back together. And we'll show you how she's working now. All right. It'll take a minute or two for it to warm up, and I'll show you how the headlights work.
won't have to wait. Look good.
All right, this is what the headlights are. And there you go. Of course, now this is a stock L48 engine, and it's still a little rough, even though the odometer says it's about 60,000 miles. And I'll show you what it looks like with the headlights on.
All right, I believe we can stick a fork in this dude. I just wanted to put this out to maybe assist someone that, especially someone that has a vet, although this would be applicable for any 60s and 70s model car that that's carbureted, that exhibits a vacuum leak. You need to find out what devices you have that are vacuum actuated, and then troubleshoot from there. Also, I forgot to mention out that sometimes the vacuum could be, if you check all your devices and it doesn't change. In other words, none of your vacuum devices is causing the problem, but you still have a vacuum leak. You can take something like carb cleaner, brake cleaner, MAP gas, anything that's flammable. And what you do, of course, you remove your air cleaner and direct your spray at where the intake manifold mates to the heads, where it mates to the block, around the base of the carburetor. Now, if you get it above too high, the spray, it's going to get sucked in, and it's going to give you it's going to pick up the idle. If you spray anywhere around the intake manifold, the base of the carburetor, around the throttle linkage where it goes through the carburetor, avoiding getting any spray through the top, and the idle picks up, you found your problem. I had a 350 once that someone had put a end intake manifold on, and they put gobs. I'm talking about gobs of RTV on all the gasket surfaces, and I discovered a vacuum leak at cylinders 6 and 8. I don't know if it was 6 or 8. It was just in that area. I removed it, got me a good Edelbrock, put it back on there correctly. No vacuum problems again. I've also had a loose carburetor cause a vacuum leak. So you can utilize a spray or some sort of a flammable gas to isolate a problem, a vacuum leak problem that's not in one of the devices or vacuum lines, okay? So there you go. I hope that was helpful for you. And it really wasn't clickbait, was it? I mean, my headlight assembly was causing my rough idle. Not really the headlight, but you know, that may have got your attention. So anyway, I'm in the middle of replacing some cosmetic stuff on the interior of this. I'm mechanically sound. Now I'm wanting to get the thing to look as good as it runs. So that's going to be a whole nother process. So anyway, I hope everything's going good with you and yours. Everything's going great here. Can't complain. Won't do me no good to complain anyway. Although here it is, we're almost at the end of April, and I'm wearing a sweatshirt and long pants, when a week and a half ago we were in the 80s. Oh well. So anyway, like I said, won't do me no good to complain about it anyway. Just take care of the business and carry on. So have a good one, and I hope to see you around on the next one.